Alright, welcome back to HED 241 Biostatistics in Public Health. It's Dr. Purvis. We are on Part D, Inferential Statistics, Section 17, Variations on Random Sampling. Alright, so we talked a little bit about this in the first section, so like in Section A. To remember, a population consists of all members of the group of interest to the researcher. That's the population. Also, the larger the population, the more likely the researcher will study a smaller sample of the population and infer that what is true of the sample is also true of the population. We call this generalizing from sample to population. So remember that a sample is a subset of the population. Here's an example. So, population, a small one would be all social workers employed by a public hospital in Detroit, probably about 20. Large would be all social workers in Michigan, 240,000. Okay, you're not going to be able to sample and ask questions of 240,000 people. 20, you might can, but you're going to take definitely a sample of the 240. Okay, the larger the population, the more likely a researcher will study only a sample of the population and infer that what is true of the sample is true of the population. So that's what I just kind of mentioned on the last slide. With the really large ones, you're definitely, going to take a sample. So I keep using the word infer on the last two slides. So generalizing is when a researcher infers that what is true of the sample is also true of the population. So the researcher is generalizing from the sample to the population. So when I say that a researcher infers, that's the way the researcher interprets, is another word for that. Okay. Freedom from bias is the most important characteristic of a sample. Unbiased sample is all individuals in a population have an equal chance of being included as a participant. There can be no favorites. So we talked about this again, I think it was part A. So just as a quick reminder there. Simple random sample is the basic method for obtaining a unbiased sample that is being used to random sample from a population. So simple random sample is a basic method for obtaining an unbiased sample. It's just the most basic way to random sample. Okay, let's look at some examples. Okay, so if you want to do a simple random sample, you're going to draw participants at random. So maybe you put all these people's names in a hat. You're going to draw randomly, and maybe that's who you get. Okay. You can do the same thing with numbers. You can assign people numbers, so then, go through and say, every person has a number. That's how I grade. I'll say that. It does it anonymously, and so it does it with numbers instead of your names. So going through and it just sorts them randomly. So it's not like you're going in order alphabetically or anything else. So that's another way to do things. Okay. A stratified random sample is usually better than a simple random sample. So here's your population of people. So we could separate this population into sex, men and women. Okay, so each stratum is going to be some characteristic, some variable that you're using and think it could be important to your research. So here we're saying that it's sex. Okay, so now you have separated them. Males over here, females over here. Now you're going to draw participants at random from each of the stratum. Okay, so now you draw them randomly. Okay. So with a stratified random sample, okay, you separate them based on some characteristic, some variable that you want to make sure are included. Okay, so let's do another. We're going to talk about one other way you can stratify, and I'll give you another example. So multi-stage random sampling. So large-scale studies, okay, so when you're talking about all the counties in North Carolina, you're going to draw a sample of counties at random from all counties in the state, okay? So draw a sample of voting precincts at random from all precincts in the county previously selected. Okay, so you're just going to draw the sample. So when you go back to this one, so draw a sample of counties at random. Okay, so you're going to draw the counties at random. Then you're going to draw a sample of the voting precincts at random from those counties. Okay, so you're saying, so maybe you pick, looking at this, I don't know, you pick Wake County, Lee County, and Wayne County, or you're randomly selected. Okay, then now you're going to go in and say within Wake County you're picking a certain number, you're going to draw randomly maybe 4 precincts, Lee the same and Wayne the same. Okay, that's a multi-stage random sampling. So you've already had one set, you've randomly sampled once, now you're doing it again from what you already did. Okay, so you draw individual voters at random from all the precincts that were sampled. So first steps, let's go through them. You draw a sample of counties at random from all the counties in a state. Then you draw a sample of voting precincts at random from all the precincts in the counties previously selected. Then you're going to draw individual voters at random from the precincts that were sampled. Okay, so first you randomly sample the counties, then of those counties you randomly select precincts. Of those precincts you're going to randomly select individual voters. Okay, so it's multiple steps. Okay, to make it stratified, okay, you could first stratify the counties into rural, suburban, and urban. Then you would draw randomly from those 3 groups. This would guarantee that you have a representation from all types of counties, thinking rural, suburban, and urban, whereas when you just randomly sample, there's no guarantee. Okay, so if you want to make sure that it's going to be very accurate, then you want to do it this way. Okay, think about it this way. We know that traditionally, this is a generalizing statement, when you're talking about voting, rural counties typically vote Republican. Urban counties typically vote Democrat. There are exceptions to this. Okay, but if you ended up with all urban counties randomly selected, and you're looking at voting precincts, and you're looking at how people individually voted, but all of your counties are urban, you're probably not getting an accurate picture of how people in the state actually voted. Hopefully that makes sense. Okay, the last type we're going to talk about. For random cluster sampling, all members of a population must belong to a cluster. Okay, so a cluster is a group that's already existing. So think like a team, think like Boy Scouts, I think is an example in your book, think a classroom. Okay, so then you can sample randomly the clusters and not just the individuals. So let's do SEC football, or let's just do football. Okay, NCAA football. So first you would say you're going to look at D1, Division 1. Okay, then maybe you say you're going to look at a specific conference. So you're going to look at the SEC. Now you only want to select maybe 2 schools. So you're going to put all the schools, I think there's 14, in a jar, and you're going to pull out 2 names. And then everyone on those 2, maybe you're looking at football, those 2 football teams are going to be sampled. Okay, so it's not that you're now randomly selecting the individuals on the teams, but you're randomly selecting the teams, which is also the cluster. Section 17 questions. Make sure you can answer all of these for your exam, even the ones that are not necessarily assigned. If you have questions, definitely please let me know. Have a good one.